on example 1, there are a few places in my stat lab where they use a couple words that we have not talked about. So they are interpolation and extrapolation. So interpolation, the prefix means between. So when we're asked if we're on some of these equations, we're going to be asked if we used interpolation or extrapolation to make the prediction. Interpolation is when we predict y for an x value between, so it's the prefix that means between x min and x max. Extrapolation, the prefix extra means outside or beyond. And so this is when we predict y for an x value that is either less than x min or more than x max. And typically it happens when we're trying to predict something way in the future, so way beyond the data that we've actually collected. So this is typically more the case where we project out in the future beyond the last year that we saw. So like in here, this particular answer that we got here, we used extrapolation. Because for this particular data set, the collected values in the data, x was between 0 and 20. This is our x min and x max. But the x that we plugged into the equation was 28, which was beyond our value of 20. It was outside the scope of the data that we collected. All right, so moving forward. So estimating the max or min value of a quantity. So remember that the graph of a quadratic function, f of x equals ax squared plus bx plus c, where again a cannot be 0, b may be 0, c may be 0, has one of two shapes. So in looking at this given equation, its coefficient on x squared is either positive or negative. Again, it cannot be 0. Okay, so when the coefficient on x squared is positive, we get a parabola that opens up. Okay, the part of the parabola that's open is upward. And in that case, right here is our vertex. And this vertex will be a minimum point. As we travel left to right across the curve, okay, that is the lowest point that we cross through. But now if the coefficient on x squared is less than 0, if it's negative, then we get a parabola that opens downward. So the open side of the parabola is down, and in this case our vertex is a maximum point. Again, if we were to think about traveling along this path from left to right, we would basically reach the top of the hill, okay, our highest maximum point here at the vertex. So now recall the following from section 9.2. So in 9.2 we looked at some patterns in some different problems and discovered that this x-coordinate for the vertex always happened at the point where we were looking at the opposite of b, and then 2 times a for our denominator piece. So the opposite of b over 2a. And then if this is going to be a point on the graph, okay, so our vertex is on the graph, so it has to satisfy the equation. So we plugged this value of x in to see what the value of y had to be to make that equation true. So then we just took f of this particular point. So now we're asked to use the data below to answer the following. So we were given price per item and the profit in millions of dollars. Okay, so this is our explanatory variable and our response variable. So in the graph scatter diagram that's been given here, this is our price per item, and this axis would be our profit in millions of dollars. So we're asked to use the quadratic regression feature on our calculator to find the equation of the best fitting parabola, and we're asked to round the coefficients to 3 decimal places. Alright, so let's clear off stuff from our last problem. So let's go into y equal, and we're going to clear out that last equation. And let's go into stat 1 and put in some new data. So in L1 we're going to put 10, 20, 30, 40, 50, and 60. And let's clear out L2. And in L2 we're going to put 57, 86.2, 99.4, 86.2, 73.6, and 53.2. So now to make the scatter diagram that is pictured in the notes, we could go into second function y equal. Again, make sure plot 2 and 3 are turned off. So we're going to choose button 1 for plot 1. Make sure plot 1 is turned on. And then we want this first graph. So if currently something else is highlighted on your screen here, you're just going to move that highlighted region to the scatter diagram and then push enter to make it stay there. All right, then x-list, my x-coordinates were in L1, my y-coordinates were in L2. So we're going to push zoom 9. And we see the graph here on the calculator that matches the one that's given here in the notes. Okay, so now we're asked to use the quadratic regression feature to find the parabola that best fits this given data. So we are going to go into stat, over to calculate, and we want quadratic regression, button 5. And again, we have to tell it where the data is. So my x-coordinates are in L1, comma, y-coordinates are in L2, so second 2. And again, I want it to store the equation so I can see its graph. So I'm going to put variables over 1, 1. So again, it's going to find the best fitting parabola using what's in L1 as the x-coordinates, using what's in L2 as the y-coordinates, and it's going to store that equation in y1. So again, here we get our output screen, and again, we're looking for an r squared close to 1. How close is close enough? We don't really discuss in this particular level class. But again, r squared is bound between 0 and 1, so at 0.94 we're getting really, really close to 1. So it asks us to round those coefficients to 3 decimal places. So again, our profit for a given x, we estimate that that would be negative 0.063 x squared plus 4.19 x. And I guess C did just come out to be 24.4, so 24.4. So now it asks us to use the equation in part A along with the vertex formula to find the maximum point of the graph. So to use the vertex formula, we need all of our terms on one side, which they are. So here's our coefficient on the x squared term is A, here's our B, and here's our constant term. Okay, so for the vertex formula, okay, so x coordinate of the vertex is the opposite of B over 2A. So we're going to get the opposite of 4.19 over 2 times negative 0.063. So So here the opposite of 4.19 is negative 4.19. And twice this quantity we get negative 0.126. And when we divide, we get about 33.25. So again, that's the x-coordinate. So again, the vertex, or this maximum point, should have an x and a y-coordinate associated with it. It is a point on the graph, and so we're going to plug this point in the equation to see what the y-coordinate would be. So to get the y-coordinate of the vertex, we need to plug this number into our function, but that function we stored in y1. So on the calculator, we can do variables over 1, 1, and then tell it to put in an input of 33.25. And we get rounded off about 94.4. So this is about 94.4. So if we interpret what that actually means in context, so again, the input here was the price per item, and the output, if we go back up to the table, was profit, and that was in millions of dollars. So if we want to interpret that maximum point in the context of this problem, it tells us that if the price per item is about, we set it to be about $33.25, we predict, or we estimate, that the company will make a maximum profit of $94.4 million. Okay, so in part B, not only do we have this ordered pair on the graph, so we could interpret this that when the price is $33.25 per item, profit will be $94.4 million. But this isn't just any point on the curve, this is the vertex. And in this case, we have a parabola that opens down. So here, A is negative, which tells us that the vertex will be a maximum. So if we actually go back to our calculator now and hit zoom 9, you can see both the graph and the parabola, and what we just found is this point right here, okay, that max point at the top of the parabola.